Okay, good afternoon, everybody. Welcome to 2026. Oh my. This is Chem 213, yes? Okay, everybody's in the right place. I am Professor Hein. I'm an organic chemist, physical organic chemist here on campus. Today we're going to go through some of the admin stuff for 213, tell you about how the course is going to run, a little bit of introduction for what I do and what my background is, and give you some just overarching stuff about this course. So first of all, I'm Jason. I don't like the whole prof thing, whatever. Literally, if you email me, I'm Jason. That's totally fine. That's my email address, jhein@chem.ubc.ca. I have not set my office hours yet. It will very likely be on Monday, sometime today. If there's times that does not work for you, again, what I will usually do is I will book a room over in chemistry. You guys can come over. I do not prepare material for office hours. Please bring your questions, your interests, and things like that. We'll discuss it in there. I've got a blackboard and a room that we can kind of go through. There will also be some tutorial components from our awesome TAs. We'll talk through that sort of parts of support as well. First off, this is one of the more important members of the Hein Lab team. This is Lucky. He was a chick for Christmas this year. He's my little buddy. He may show up a little bit, both in some of the material. He's an epileptic dog, so he has to follow me around quite a little bit and stuff like that too. If you look on our website, he's also our HR manager for our group, but he is awesome. About me, what I do in terms of research, I am what's called a process chemist or physical organic chemist. Does anybody know what that means? Who wants to be a process chemist? Shrug. That is the correct answer. Anybody who puts up a hand, you're kissing butt. That's probably not true. So I started off being really interested in organic chemistry. I'll tell you a little bit about my background. Basically what that means is for process chem, I do this. We have to look inside reactions to figure out why they are happening. Often we're called in when something is not doing what it's supposed to do. So we're kind of the special forces that gets called in when chemical manufacturing has to happen. In other words, we're doing processes. We're looking at how do I take that and make this every day on a manufacturing process where we have safety, we have cost efficiency, where we are not going to blow up the plant or something else. Most of that is what we focus on. So it's not just about using organic chemistry in synthesis, it's understanding analytical chemistry, understanding thermodynamics, understanding physical chemistry, chemical engineering, and now what that's really turned into is this. Everybody's vocation is now focused on things like automation, robotics, and AI. That's a huge chunk of what my group works on too, is because we're augmenting what we used to do in terms of classical organic chemistry with now modern tools and modern digital tools to actually do this, where we're using the broader scope of what we have available now. So my group is sort of a hybrid between classic organic chemistry and manufacturing, as well as hardware design and robotics. So my origin story, I started at the University of Manitoba. Anybody know where Manitoba is? Anybody from Winnipeg? Oh, yes. So you understand what it means when I say I'm a Jets fan? It means I'm really, really good at disappointment. I was at the last Jets game before they became, we not speak of them, and then I was there when they came back again at the downtown site. So yes, the Jets are near and dear to my heart. I was also a power defenseman until I was 16 years old, and the fifth head injury put me down at that point, so I am a classic Manitoba hockey guy. This is my PhD advisor. His name's Phil Halton. Phil was a phenomenal mentor. He taught me how to, not only to teach around this, but also how to do research. Like, he was one of those people that created a sandbox and basically said, look, it's up to you to figure out how to do what you want to do. It's up to you to figure out how to actually run your research group and things that you're passionate about. That's what I used to look like. It's not that far off, except if I got a more shiny now. But the thing we really focused on, the thing that Dr. Halton did different than anything else, is he told me, as an organic chemist, you are the architect of matter. Your job is to figure out how to take some material and create what you need for some purpose. As a chemist, a synthetic organic chemist, you are one of the only people that can actually create the thing you need to study. I don't care about biology, I don't care about anything like that. No, organic chemistry is the real. If you are a control freak, this is where you're right home, right? Especially when you actually start to apply this for things like manufacturing. I worked on this project. That was the molecule I had to create for my PhD. It was a molecule that actually both allows synthesis to happen easier. It's a template. It also has chirality. Do you know what these wedges and dashes mean? Oh, everybody better nod. What does that dash mean? That means it is going which way? Into the page or out of the page? Into the page. Don't worry, it's the new year. We'll shake the dust off. Dash line means it's going into the page. This was a molecule that has a very specific shape. If you attach things to it, you can guide the shape of what you're building, so it's a template. But it also had this little RF. RF is like a little piece of Teflon. It means I can selectively pull that molecule or anything attached to it out of everything else. It's a way of labeling it and then isolating it. So you could do reactions using this as both a surrogate, like a shape, but also as a way of recovering material. It required me to do some really, really interesting sort of chemistry to figure out how these things work. These like C6F13 molecules are very different. It uses chemistry at that time that if you got it wrong, it sort of started on fire. Nice thing about doing this in Winnipeg, if anybody's been in Winnipeg in winter, so again, you know this. My dad used to say Winnipeg in winter is colder than Mars. That's true. There are parts of Mars that are actually warmer than Winnipeg in the winter. The nice thing about that is there's very, very little moisture, which means that reactions like this that are very water sensitive work great in Winnipeg. So this is partly how we were able to do this at the University of Manitoba. The problem with all of this chemistry, though, is this took years. I took 5 years to get really good at sort of very simple reactions like this. It is a huge amount of time and effort getting sophisticated enough in terms of your technique and your technology to do what looks like very simple. And in fact, these are reactions we're going to study here in class. Doing them in the lab takes a lot more time and effort. This is where I wanted to learn more about how to do these reactions and how to do the control. I went to go work for Barry Sharpless for my postdoc. This is at the Scripps Research Institute, so I jumped from Winnipeg to San Diego. I moved on December 3rd, and I slept on a floor in a San Diego apartment for about a month and a half with no furniture. It was a great Christmas. Barry Sharpless is most well known because when I joined the lab, this was right after he won his Nobel Prize for doing what's called asymmetric synthesis. The molecules I built were these chiral molecules with these particular shape, and their job was to enforce shape in another molecule. They basically transferred shape to something else. It's like doing a lock and key or handshake. What Barry did is he came up with a way of doing that catalytically. He made basically synthetic enzymes that could produce catalytically chiral or shaped molecules, which is a huge deal. Does anybody know this guy? That's Louis Pasteur. Louis Pasteur was the original sort of synthesizer of chiral molecules. He did this separation where he took tartaric acid and he split them into the left and right-handed shape as crystals. It turned out that this is one of those molecules that you can get one enantiomer crystallizing as one molecule, and with tweezers he could separate them. Until something like what Barry did, doing this routinely on a routine basis was almost impossible. And his research career leading up to 2021 was focused on this, which won him the Nobel Prize. This is why it was so fun to go and work in that space. After that, though, I got to work on a new chemistry. Barry was focused on what he called efficient chemistry, or what he later branded as click chemistry. Click chemistry's idea is that if you can put molecules together routinely, just like you stick together like Lego bricks or like a USB plug, it's really, really helpful. It means that an organic chemist or a synthetic chemist or a biological chemist or even somebody from biology or physics can take these kind of click reactions and run them reliably. So he was focused on coming up with kinds of reactions that always worked, no matter what happened, drop of the hat, none of the special like, oh yeah, you know, an SN1 reaction looks like this, except proviso, wrong solvent, ha ha ha, got you, right? Like we all know this. Organic chemistry, the hard part is organic chemistry is kind of like jazz. There are rules, but there are so many conditions, and variables, and I'm going to teach you how I learned it, right? I'll try to get you guys up there. But what Barry was focused on that time was come up with reactions that always could work reliably. This was his focus after click chemistry. So this was the reaction I came up with. It's my version of one of the click reactions. It allows you to stitch together these azides and these iodo alkynes to create molecules like this, these iodotriazoles. These are really useful for things like PET imaging and things like that. It was my very first, this is the whole research project I got to live and do off of. Cool thing about this is not only did I get to run this, but this was actually part of Barry's second Nobel Prize. So my research got to contribute to Barry's second Nobel Prize, where we got to go down and celebrate this point. Barry is the only living person now, chemist, that has two. So what's really funny is at Scripps, there's a parking lot. At the front of the parking lot, there's a banner that says reserved for Nobel Prize winners. Because they have actually collected a couple, Barry got a special spot that says no reserved for double Nobel Prize winner. It's still not the closest spot though, so I'm not sure what else he has to do. So I've had a lot of fun in this space. I've done a lot of different things. After working as a postdoc with Barry for a couple of years, I learned reaction kinetics, I learned mechanisms. I started my research group, and I started at what was called the University of California, Merced. Does anybody know where Merced is? Oh, awesome. It's almost like Winnipeg, but for California. Literally, if you throw a dart at Canada, you're probably going to hit Winnipeg, dead in the center, right? If you throw a dart at California, you're probably going to hit Merced. It's inland from San Francisco. It's just on the other side of the Sierra Nevada mountains. So this is looking up into Yosemite National Valley, is like up that way. It was phenomenal. Brand new campus. It was the first brand new research campus started in the 2000s. We started in 2025. Does anybody know what happened to the world in 2007, 2009? Yeah, massive recession. That was fun. There's nothing like being a brand new school right in the middle of a global recession. It meant that we had to get creative. You know, your research programs had to adapt because unlike Berkeley, unlike UCLA, which had these massive endowments that could weather the storm, we had just opened our doors. So we had a lot of work to do. And in fact, this was really interesting because the campus was basically 95, 96% brand new faculty right out of your research career. Or nobody had any experience. So it was like the Wild West. It was a lot of fun in terms of setting up a campus, but it means they've had a lot of experience, not just building teaching programs and research groups, but an entire sort of research structure. From there, though, the programs we built up eventually graduated into what we have here. University of British Columbia saw what we were doing in terms of my undergrad training program and the modern sort of mechatronics that we were doing. The way we survived that global downturn was to say, look, we can't do science the way we've been doing. If we need to be more efficient in what we have, it means we have to use tools outside of your classic organic chemist, which means we started pulling in things like robotics, AI, other components way early. We were cool before ChatGPT was doing cool stuff. Like we were doing this stuff back in 2010, 2015. So that's what grew my group out. This is one of the kind of more recent pictures of our group here on campus. One thing I'm really proud of, though, is people like Veronica here. These are people that started as my Chemistry 123 students. They've ended up joining the group, doing research as an undergrad in my group. I actually started a startup company where Veronica is now one of the leads of R&D. So I kind of accrete people, and I'm very happy to the family we've sort of built out in this way too. So it's something that I really enjoy about how we do our research. We've come up with really interesting ways of doing organic chemistry. And again, part of this is having a platform like this, a robotic system that can do the chemistry, means that technically I can be here in class, I can tell that to do something, I don't need to be there. So during the next big crash, you know, something happened in 2020, yeah, we did not have the same problems that everybody else did. Why? Because I can dial into my system and I can still do chemistry. We were social distancing before social distancing was cool too, because it means we can now do remote chemistry. In fact, we have research labs and collaborations in Korea, in Norway. We have a global presence around what we do just because chemistry is a global art now, right? And having tools like this means that we can reach outside of just sort of what's in the lab. So if you're interested, we do have a YouTube channel for my lab. The lectures, as we go through, I am recording them. So all I'm recording is actually this, the screens, not the lab pointer and stuff like that. You get to see this, and you got my voice. I'm not recording the visuals and stuff like that of the class. But I will post them up on YouTube. What I also post on YouTube is really cool stuff from our group. So we have a whole bunch of different quick demonstrations. These are things that we're working on in the lab. This is actually something that was done by our group during Valentine's Day, where the Universal Robotics is asking the Canova out by passing it a nice little Valentine. And then very, very shyly, it goes through and says, actually, I've got this one other thing here. will you be my Valentine? And on the other side, we've got the Canova, also very sheepishly going through, picking up a pencil, and we're actually using computer vision and tracking to say, maybe. Again, this is a joke, obviously, right? This is some fun stuff we get to do in the lab. But behind here is basically the skills and training to get anybody who doesn't want to be near the lab doing organic chemistry, right? This is where we start off of building the code bases and the components from this is what we can then transfer into full research and R&D. So if you're interested, please like and subscribe. But two parts. Like I said, our YouTube channel will be where you're going to get your lectures. My fourth year class is also on there too, so if you're interested, you can watch the fourth year class lectures. We have videos from the lab of stuff that we're doing, so these are other robotic interest points or parts of our collaborations. So do please pay attention to that part too. It's a good way to get our stuff out. That's me. That's my origin story. That's why I do this. That's why I like this part of it. Welcome to Chem 213. I want to start off on this point, though, and take a couple sections. I want you guys to reflect on these things. Why are you here? And it's totally fine if most of your answers are, because somebody told me I have to. That's fine, right? This is a course that's part of your a main course of whatever's happening here on campus that is a centerpiece to a lot of different degrees. And I fully expect that you guys are not all going to be organic chemists. Again, if I can convert some of you, dark side kind of way, awesome, that's great. But I want you to reflect on some of these pieces, too, in terms of what you think your success looks like. It doesn't have to be you are an organic chemist. The things I really like about organic chemistry is the problem solving and skills that you can apply that you learn from being an organic chemist is ubiquitous. And I'm trying to demonstrate that with my research point. I was trained to mix hazardous flammable things with other hazardous flammable things. And most of the times it does not want to do that well. So it means you have to figure out and problem solve live. In the most egregious version of this, have everybody seen The Martian? So my movie references are slowly being updated. I used to use older ones, and I'm trying to get a little bit more up to date. The point is, everything you do in the lab about the experiment you're trying to do and why you're trying to do that is a series of very abstract problem solving. That is really organic chemistry, and that's the piece that I hope I can impose on you guys of why you're taking this class. Having that skill of taking an abstract concept and figuring out how to get through it is the valuable part of taking this class, even if you're not going to be an organic chemist, and I hope I can help you with that part. This is our course resource. This is not a required textbook. This is a recommended textbook. I believe it's in the electronic version, should be as part of the bookstore. You can find this in a Kindle version. I'm pretty sure there's a free PDF download of it. The only thing that matters is this particular one and the 8th edition will match up with the problems I'm trying to assign. So this is meant to sort of say that these chapters are helpful in terms of course content, but mainly the Canvas site will be your main point for both lecture material, secondary problem sets, things like that, practice exams. That's your main kind of output. Resources like this are useful just because it provides another way to explain concepts and give you more practice depending on what your background and stuff is. If you can't find this specific one, almost any second year, first year organic chemist textbook will have similar concepts and stuff. It just won't match up in terms of the problems I'm physically assigning. Things that will be helpful. If you have problems with spatial reasoning, model kits are very useful. These are 3 examples of them. Again, optional. The scientific calculator, optional. I don't think we're going to do anything with it, but it's on the list of this is an allowable resource for things like exams. But there is no delta G calculations. There's no enantiomeric excess calculations. We are just doing synthesis primarily. The way that we're going to break down our grades is one of 2 options, and you do not need to select. I will score all of your things according to this point, and I will award you whatever the highest one is. So in other words, if you maybe don't do too great on midterm 1 and you absolutely crush it on the final, your final will just be weighted higher so that you get the better mark of whatever's possible there. So again, this is not optional. You don't have to choose which one. I will just subscribe you into whatever one that's possible. Basically, we break it down where you have your Canvas quizzes, 2 midterms, and your final. You have your Canvas quizzes are going to be set up where there will be a total of 6. I will take your best 5. Again, you do not need to tell me which one you want to do. I will throw out your lowest score. You can have 3 attempts for each quiz, unlimited time. In other words, you can start it, you can try it as much as you want, you can learn from it and fail, go back and try again, right? And again, these are not timed events. The only thing I ask you, please, 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 they will always open on a Saturday, and they're due on Friday at 5 p.m. Pacific time. please do not start your quiz at 4:25 of your first attempt. The whole point of giving you plenty of time is to try and fail and try again, right? This is meant to give you as many options to just try this thing and work through the problems, because most of the times I'll try to set up questions which probably follow something in class, but there may be something that I'm asking you to pay attention to. And the first time through, you're like, oh yeah, definitely, it's R, it has to be R. And then you get it wrong, and you're like, well, Jason clearly had an error on there, so I'm just gonna email him and say I want that point back. No, it's probably set up that way that I want you to go through. You took the bait, you took the question wrong, go and look at it, reflect on this. There's probably a reason we've set it up to catch you in that part. It's not that, I'm not saying that I don't make a ton of mistakes. I do make a ton of mistakes, but start with this whole point, and having these multiple attempts and unlimited time is meant to allow you to look at the question, go back to your notes, reflect on it, try it, talk to each other, and then go through your answers, right? And I fully expect you guys to talk and help each other. That's the whole point of this. The best thing you can possibly do for a class like this is work as a team to teach each other. The best thing that ever helped me as an organic chemist is to help explain what I know to somebody else, because it helps me reinforce and understand my own area, but it also helps me to see why you don't understand it so I can rephrase or change how I'm teaching something. So this is really important to do this as an active point. This is not recollection. This isn't math. This is something where you have to understand this almost like you're learning a language. So practice is key. These are our two dates that we've set up. We've set the midterm for February 9th and March 16th. Quick poll. Does that automatically overlap with somebody else's exam? By 2/3. Okay, so shoot me an email. I have to check how many people get impacted by that one. I can move them in that point. But the whole point is these are the two that we've set that sets us away from having to study over midterm break. And it does fit well with our sort of timing. We may move it a day either way to stay away from something else, but if there is an overlap that is a major conflict, please shoot me a thing now and we'll get it corrected. Yes?
At what time on those days?
They will probably be at 6:30, so it'll be evening, right? Okay, so that's homework for you guys. I want you to review your courses points, shoot me an email, and we will reset this if we need to. Quick point about the exams. Has people done two-stage exams here at UBC? If you've done 233 with Jay Wickinden, you may have done this already. A two-stage exam means you will have an individual phase where you get to write the exam. It's you versus the exam yourself. Closed book, that's it. After that time, so you have 75 minutes to do it yourself. After that time, you guys group up as a group of 4. You will be given questions, same or similar, and you'll be asked to do it again. And you'll be given a breakdown where up to 20% of your midterm will be awarded based on your group exam. In other words, if you totally bag it on a question on the individual part, you have a chance to recover when you work as a group. So this is why it's very useful to actually participate in this, because live, you can try the exam, you can see where you have a failing or a problem, and then you can work as a group to figure out why you didn't understand it that way to get it right. In general, final exam will be during the exam period. I don't know where it is. We won't know until probably sometime in March. The main thing here is do not plan travel during this time. You are obligated to be here during that time, and you can't sort of say, oh, well, I can't write this one because this awesome Taylor Swift concert or something else like that. Roughly 2.5 hours will be cumulative in terms of all material in the class. If you have any other exam conflicts, everything else, do go back to your faculty advisors to kind of work through this. We also have, I've mentioned this part before too, if you are sick before a midterm, there's just a website, and it's part of the syllabus. I think we've got it listed there. If you're sick, you get into an accident, something happens and you cannot sit or attend an exam, that is fine. You do not need to bring a doctor's note in. You fill out a form, say you're declaring a concession. You will not have to write that exam. That exam will now be part of your final. Again, you guys are all adults. In other words, both parts of this is if you choose on your own to say, midterm 1, nah, not feeling it. Midterm 2, nah, not feeling it. Okay, you are doing something very silly because you've never written one of our exams and now you're betting it all, 95% on the final? No. I've only seen one person in 15 years of teaching do that well. Do yourself a favor and participate. But what I'm saying is it's meant to decompress, and I understand you guys have to set your time according to what makes sense for you guys. You have the flexibility to say, for whatever reason, I can't write this exam. That's fine. But what I will say is that if it does come down and you're like, because of a standing deferred, you panic, something else goes wrong, and you don't want to write the final, and you have missed one of those others exams, you will not be guaranteed a standing deferred. Because why? You didn't complete enough of the coursework to justify a standing deferred. So remember, this is one of those things where you have the full power, you get to inherit the consequences as well too. Okay? All right. How practice material. Right now, there is a practice problem set. So here we're going to have a list, and we will populate it as we go through. So this is one part where this is my third year teaching 213. Last year, we focused on bringing the content into focus. It's the same content and the same slides. This year, we're going through and rebooting all the problem sets. This takes a lot of time. I have the old problem sets. I can make those available. These were originally developed by Dr. Perrin for a course 3 years ago. They are practice material that is useful, but I'm flagging it as it is not fully relevant to all the content that we create. In other words, he's talking about reactions that we no longer cover because I've updated the course content. I'm happy to make those old legacy ones available if you need other practice as we're developing this point. But the thing I'm asking you guys is you're not going to get all the problem sets for Chapter 6 right now. They will be developed as we go through, and you're going to have to follow along at this point. So it's a live update. Yes? I'm not telling you that. That would be rather silly. They would be similarly inspired, but there's different versions of similar questions, put it that way. Anything else? You got unlimited time in 3 attempts. I can't make it that easy. But you will get the general gist of it. Yeah, anything other questions on the problem sets? Again, so this will be evolving and rolling as we kind of go through. One other part of this too, again, I'm happy to make the legacy problems available. If you have problems working through them, those are good things to bring to things like office hours or a class tutorial with the TAs. The content schedule, generally, we've got on the Canvas site, I'm going to be posting in advance of every lecture a preview. So these are slides to give you stuff to look at before the class. After the class, you'll get the full slide base. So this includes other slides that are not posted in the preview section. These are like questions, quizzes, other material that I'm updating on the fly. And then you'll get a post one. Any notes that I take in class, any annotations I make will be posted off. So you'll have 3 PDFs for every lecture. A like the preview version, the performed version, and then the after version with all the notes. So the lecture slides and recordings will also be up as well. Ideally, I try to get this up here. This also whereas if we have things in class where I have a flag where I said, here's a problem similar to what we've worked through in class, go ahead and try it later. I will not work through this in class. I will record it as a pencast, and I will append it to the end of the lecture so you can go and review those after. So you will have to, if there's things in class where there's work problems that we don't cover in class, they'll be in the lecture recordings at the end of every lecture video. And I'm not just doing that for content engagement. Right now, YouTube still does not think what we do has any relevance or value. Major things. In class, I will make my handwritten notes available. If you have other things available, again, it's a good thing to bring something to class because, again, part of what we're doing here, organic chemistry, is very a tactile thing. On the exams, you're going to have to write and draw molecules. You're going to have to actually do the kinds of things that we see here in class. That only happens with practice. Like if you've never really practiced drawing benzene, drawing things with certain bond angles and everything else, if you wait until your exam to actually practice those things, your penmanship is going to be really bad. I don't know what you're saying. It's going to hurt your sort of general part. Mechanisms too. If you have something you've done in 233 or 203, drawing proper mechanisms with arrow, electrons, bond movement, this is something that happens with time and practice, so it's very good to bring things like your notes in class to do your work. In general, as you go through the material and you're making your notes, adding things like comments for both the slides that I provided, but also your own notations as well. These are things to help you to go back after the fact and review material. As I've said before too, I am recording both the audio and the video part of it, so you can go ahead and review it. If you have your own sort of tools that you want to use in terms of like audio recording, don't go for it, no problem like that, that's totally fine. Whatever sort of technology helps you and that works in your point, that's something that we can discuss. If you want suggestions and what also might help based on your own networking or your own note-keeping kind of ways, I'm happy to discuss what works for your learning style. In general, Any notes are better than no notes. In other words, basically just engaging with the class rather than sort of sitting here and watching this as a video, or just saying, I don't feel like going today, I'll probably watch the YouTube video later. That's okay, but again, what you're doing is you're deferring that time and to actually sort of engage with the material. It's much better to show up in class, ask questions, actively engage with it as it's actually happening, rather than just, well, I'll probably watch 20 videos. Again, nice thing about having on YouTube is I've got the video watching. You have no idea how the video watch count goes up just before the midterm. It's amazing. In general, class etiquette. This is a big class. Like I've said before too, I like doing this. This is kind of the front of the room kind of engagement part of this point. This is a respectful environment for that point. We are all academics in this space. Ideally, we don't be polite to each other. Please do not be hostile. We have had cases where, again, this goes back to YouTube, what do you call it? Nuisance streamers. This is something that's happening a lot more on campus, where somebody will come into class wearing like Bermuda shorts and like drinking Coke and burping loudly. These things happen. We will deal with them as accorded. But please, everybody who's here right now, promise me right now you're not going to do one of these kinds of things. There's no need for us to all be TikTok stars. There is a class Piazza. This is your link. Please go to this link. Please sign up for this link. If anybody who's engaged with Piazza before, you understand what this generally means. It's a platform for you to post and ask questions. It will be monitored by myself and the TAs. Ideally, this is meant to be something where you can post a question. In general, I like to hold back a little bit to let you guys talk it out yourself, and then I can help to engage or oversee. So I'm going to try and keep a light hand at this, where I'm not going to like, every post goes on there, I want to get a 30-second sort of reply and point thing. This is meant to be something where you guys can help working with each other to talk through a problem. What you'll notice, especially if you watch Piazza, is there's a lot of the same questions coming up over and again, which helps you to feel like if it's something you don't understand, there's other people in the class that feel the same way, and there's ways of you guys to work through this one. So this is where the useful way to use Piazza in that way too, is please ask and answer. These are our two course TAs, Sarah, Rebecca up at the back. Hi. These are awesome individuals. They are my graduate students. They are here and available to help you. So if there's a lot of other content, if you need another visibility about how to teach something or how to learn something, please use them as well too. These are their email addresses. That is a lie, right? Yeah. So it's not going to be on Monday. Again, we're setting up the times right now. The tutorial will probably be on Thursday. We will find a classroom here. And again, what it'll be is engage with them. They will show you how they're going to run this one. This is meant to be another sort of fixed point of time where you can go in your schedule and engage with them and other material and talk through questions. Quick point on academic integrity. This is the same academic integrity policy you've seen for everything happening on UBC. The real core fundamental of this is your material you hand in is your material. That's really kind of the way that I read this point. In other words, everything that you submit, you are responsible for. This has to be what you did, your best effort. Like again, if taking this course is just a barrier because you have to get into dental school or something else, I understand that. But please, again, don't jeopardize your career, your future, anything else by trying to do something that just gets around this another component. Focus on this and engage with the material because A, I put the time into energy to try and do this part well. The thing I'm asking back of you guys, if you don't want to be here, you don't have to be here. Don't engage in other material that's just trying to go around or basically pay somebody else to write your tests and stuff for you. Be honest and be up to date. Gen AI is a thing that I love. In other words, there's nothing wrong with you guys using generative AI. And the way I look at it partly is, if I create a question that you can just do live with ChatGPT, I've made a very bad question. My view on this, again, as somebody in this space, this is a tool that everybody needs to know how to use and use it as a tool. Basically, there's never a point in this course where I'm going to ask you to write an essay which is just a prompt equals answer. That's not what we're doing here. In fact, my general rule is if I give you a question and you find a way to get one of the language models to answer it really well, tell me. I want to know these things. This is very cool. Use them as your discretion. Now, one of the problems, you guys have interacted with it too, is they will lie to you with great certainty. So if there's a point where you're emailing me saying, I think I got that question right because ChatGPT said I got it right, I'm sorry, I still win. Ha, ha, ha. But what I'm saying is you can use this as a way of augmenting your learning. Don't use this as a crutch to do the work for you. Use it as a way that can either be used to help create study questions, point you to other material, explain something in a different way. No problem. And if you're interested in it, please do tell me. You will not have access to the internet as best as I possibly can during the exam, so I do not expect you to be able to use this during an exam. But in your things like your quizzes and stuff, if this is helpful to you, if it's part of your learning style, no problem. But the line I put down is whatever you hand in, you are liable to. So in other words, if you just post on Grok, here's my assignment, what happens? And it comes back with some mega Hitler thing, then you are liable for that. Like, you handed that piece back in. Okay, the whole point really comes down to this. Do your own work, know and follow the rules, don't share material as much as you can, and again, you're liable to the work that you're doing. You're here to learn this material because at some point, I hope you're using a tool that I help to teach you here in whatever your job and your career is. And again, that's meant to be focused. Ideally, please stay away from other sort of websites like this. These are not useful ways to sort of pull material or to upload material to them. I'm happy to help you in these ways where you shouldn't feel like you have to use these materials. Emails. It is really useful to communicate with me by email. I will do my absolute best to get back in different parts. These are just certain guidelines, the same ones that I use for Chem 123. Be specific about what your questions are. Tell me what you're trying to, what information you need. Sign off with your full name and student number so I know how to get back into it. I will try to do my absolute best to get back to you as quickly as possible. Now remember, during midterm time and other times of high, like this week while things are setting up, I will be delayed in terms of getting back to you. I will try to do my best. So please do not freak out if I do not get back to you right away. All right, so quick thing about organic chemistry. This is not organic chemistry. Right? This is not what we mean when we say organic chemistry. What we're talking about is the transformation of molecules, primarily carbon molecules, from something to something else. And like I've mentioned before, I kind of work in this space, mainly over here. This is the production end of things, so less about the early discovery. We work more on once you know what the molecule is, we figure out how we're going to make lots of that molecule. But just in general, organic chemistry is a huge central part of not just the pharmaceutical industry. Anybody with an OLED screen? You know what the O part in OLED is? Organic. Semiconductors are now even something within the realm of a carbon-based material, right? So we're no longer allowed, like it doesn't mean that you just have to mine something for silicon germanium. You can now synthesize long-chain conductive molecules using the same technology and rules that we're making here in class to make materials. And this includes things like hydrogen fixation or energy applications, CO2 reductions. In general, so who gets panicked when you see this? Again, honesty, I appreciate it. Does anyone remember that first H1N1? That was the pandemic before the pandemic. You guys may have been way too young for that part. H1N1? Yeah. This was really interesting then because, again, before COVID, we had a massive problem where this one particular variant of flu, Spanish flu, called H1N1, was a huge problem. And it turned out at that time, this neuraminidase inhibitor, this Tamiflu, was one of the only molecules that people could see and say, that will actually help you in this pandemic. This is an oral medication that if you take it protectively or if you happen to be infected, this could save your life. The problem at that time was it was made from things like shikimic acid. These synthesis meant that if you needed enough of this molecule to treat the global population that might need it, we would exhaust the world supply of this molecule in a matter of a couple of weeks. So this was something where organic chemistry came to the rescue and came up with a new route to come up with this molecule using very simple starting materials. This is why we get involved. This is, again, it's about problem solving. What I hope you look at this, though, is the end of this, you don't feel like this. This is actually my niece. I'm very proud that just recently I hired my brother back into my company. He used to work at NASA. He used to be the cooler brother. Now that he works for me, I get to be the cooler brother again. But this is very telling. This is exactly what Kira, my niece, used to do when she's contemplating something like, what the crap am I supposed to do with this? By the end of this class, I hope you do not feel it this way, that you feel like they've got some tools to get through this. So, how to succeed in this course? One thing I want you guys to take a second and think about this. What are you planning on doing? So who's got a strategy? That works. Phone a friend. I mean it, seriously. Give me one thing that you've kind of come into. It's New Year's resolution time. What is one thing that you've said, you know what? I'm dreading organic chemistry. This is what I'm going to do so that I can take this class on. Give me one thing. Yeah?
Actually go to office hours.
Actually go to office hours. That is great. No, seriously. That is super positive. I'll get a bigger room. What else? Yeah?
Doing all the practice sets before trying to study this.
Okay, that works too. Yep.
Reviewing the content like on kind of weekly basis.
Keeping up with it, exactly. No, like I've said this kind of before too, just about a chemistry, organic chemistry, even more. This really is like learning Latin. It's like learning a language. There's syntax to this, and it's something that has to be done not by rote memorization. The biggest problem with organic chemistry, for anybody who's done coding, has anybody like done things like Python coding or something like that? So yeah, see, you guys have seen things like coding. Now, in Python, there's a bunch of different ways to do the same thing. There's a bunch of different functions. Does anybody use like matplotlib? Probably. That's not your only way of making plots, right? There are other packages that you can choose to use. The problem with organic chemistry, like in coding, is there's more than one way to get to your answer. And what that happens is if I say something black and white, this is how you make an ester, that's contingent. That's variable depending on certain circumstances. Nothing is like as definitive as like right and wrong. There's nuance, there's circumstances, there's rules that you have to understand to put it in context. In the same way that a language is more than just whatever Google Translate can provide. Context matters in terms of getting across information. So the number one thing that I focus and subscribe to, and again, I'm talking to this, I think I've said this, so other people may have heard this as another story. I do a lot of story time with Dad, by the way, so I apologize for that. But I failed my second year organic exam. At University of Manitoba, where I started off, I was part of a program where for anybody who was a chemistry major, we had to do one-year classes. So basically, we start in September, April is our final exam. So you all are lucky, that's one part. Back in my day, uphill both ways to school. What it meant, though, is at Christmas, that was my big midterm, and if you screwed up at that midterm, it really felt bad because you had another whole couple of months where you had a cumulative exam back to September, and it feels like you're drowning. The thing that really worked for me is by crushing actually failing my midterm in second year organic chemistry, I started to look back and see patterns. It wasn't about, I was a biochemist. That's where I started out as a vocation. I know, everybody makes mistakes, it happens. But what happens is, I started out trying to approach it the same way that I did for things like the TCA cycle. You memorize the enzyme, you memorize the structure, you memorize the enzyme name and what the pieces are. Organic chemistry doesn't play like that. You have to understand patterns and reducing it back to these basic patterns. I heard the thing about, an R group, sure. But it had to sort of make sense in what these basic patterns were. You had to break down reactions into pieces. And that only happens not from just rote memorization, but by screwing up enough that you actually start to figure out how to go through this. This is why engaging in the material by trial and error is a lot more useful. And I really recommend, if it's something you struggle with, the best thing you can do is find a study group that you can talk to each other about why the heck did Jason talk about that in class and what was he trying to say. Use the material and the things that your confusion and sit with it. It's not meant to just be easy the first time through. So, biggest things you can possibly do. Be curious, ask questions. It's not a spectator sport. You have to actually do it, especially things like reaction mechanisms. You need to draw, use the same as penmanship and other components. Studying helps, but it's not just about recopying your notes. Keeping up with them on a week-by-week basis is really important. Compressing things and waiting and putting it off it's very easy to do, especially when you have the flexibility of saying, maybe I can put off a midterm, maybe I can put off one of those quizzes. Yeah, you can do that, but you're going to pay the price eventually. So it's better to keep up with this on a running basis rather than trying to sprint to the finish. Explaining it out loud and talking to other people, again, this totally works. Make your family members suffer. If they put you in this result, it's their fault too, so help them out. And question everything, that's fine. But you also have to be accepting that my answer might be it depends for everything you say. This is something where, again, I think Jay Wickenden says this quite a bit. You guys can't be lawyers. In other words, if you sit there and go, point of order, Your Honor, you said that aluminum trichloride does this, henceforth with, I get my mark back. No, there is context for this, and this has to be something we discuss. There isn't just a black and white. That's the major things to kind of focus through. The major one I want you to do, though, is do not panic. Treat it as language building and practice. This is something we're going to work through as a team. And again, I look forward to the term with you guys. So any other questions, let me know. And otherwise, I'll see you on Wednesday.